Thanks very much everyone for coming today. And before everything starts, I want to really thank everyone sitting in this room for spending your time. And thanks for Connie and Felix and all my classmates sitting here or there. Yeah. And today we are going to spend some time on Kubernetes. And first things first, my name is Jia, and I was a DevOps engineer that works in a Japanese company. My main focus was on Jenkins and Docker. And currently, starting from April, as Kanye was saying, I'm now doing this full-time immersive full-stack web development program at Chrysalis. And something about you. I have written something here, and I have talked to some of you before everything got started. But I want to ask this again. Who here has heard about container or Docker? Would you please raise your hand? Okay, thank you. Who here has some experience that worked with or played with Docker or container? Wow, thank you very much. My objective for this session would be, I hope after this maybe 1 hour, you should be able to understand why we are doing this container things and what is container orchestration and why we are doing that. And it would be awesome if you can get an impression about what Kubernetes is and how it feels. And some places to get started if you are interested. And the approach we are going to take today is, first will be some talk, some presentation, background, and concepts. And after that, there will be some hands-on exercise, and meanwhile I will do something in parallel. I will explain this in details. So let's get started from containerization, but on a totally different business. This is a picture in 1927. It says mixed cargo being loaded onto ships. So we can see in this picture there are many shapes of cargo there, waiting for people to carry them onto the ship. And according to Wikipedia, this is something called break bulk cargo. And it seems that people were using different ways, bags, boxes, to load items into ships. And the problem is so easy to see. For example, it usually takes more time to load and unload. And actually, it's normal that a ship can spend more time on dock just by loading and unloading compared to the time it spent on the ocean. And it took more space, and things got stilled and damaged. You can imagine what was after this. And thanks to containerization, there was a long process of containerization, and we ended up with a fixed set of sizes of containers, and that's over there. So thanks to containerization, now we are able to move cargo around from all different ways: ship, train, truck. That's what we all know for today. So enough about this one. I would say that's what we learned from how we move things around. Especially cross-continent, is by standardization. So we decided to define a fixed set of containers to help us deal with this problem. And I would love to invite you to think about the question of how do we move software around? This is such a huge question, and maybe it's too broad, and I don't even try to answer this here, but I do really love to invite you to think about this. And I do have some personal thoughts, so if you are interested, let's chat about this afterwards. So, again, this time will be the continuation that you might be think what it is. So we will start from virtual machines. Let me ask you a question again. Who here has not heard about virtual machines? Okay, perfect. Seems to everyone at least heard about this. So virtual machine is a technology that enables us to run the so-called guest OS upon our host OS. So host OS could be CentOS, Red Hat, Linux, and all the guest OS could be Windows and other operating system. We chose to do this for a couple of reasons, and I believe the starting point was people want to fully utilize the hardware resources, and improve portability as well, so we don't have to handle all those environment differences problems. However, here are the problems. Usually, an operating system is several gigabytes in size, and that means if you want to boot up an image, it will take maybe 1 minute or maybe even more than that if you are using Windows. So what is a container compared to virtual machine? I would say let's just consider a container as a virtual machine without an operating system. Well, it's wrong in 1,000 ways, but yeah, it's okay for now, and let's just skip this for a minute. But to be more precise, if we are doing things in a totally different way, which means we chose to use container to package our application, there is an extra layer called container runtime, and you can see that in the picture. So what container runtime do is it provides all those guests, I wouldn't say guests, but different containers, separate and independent view of hardware resources. The technology behind this is namespaces and C groups. If you are interested, you can dig this into more details. But for now, let's just remember, container runtime is necessary for us to be able to run container. So we have talked about virtual machines and containers, and here are the comparison between those two. You can see upon infrastructure, hardware, and operating system, we have hypervisor and container runtime. And upon which we have guest OS, but for virtual machines, but for containers, we don't have that. So what's the benefit of this? As I was saying, operating system is usually in gigabytes. So without an operating system, we will be able to have a lightweight mechanism to package things. And as what virtual machine give us, container help us to provide our application a separate, independent view of hardware resources that enables us to deal with these environmental differences. So you develop something on your local machine and it runs perfectly fine. And after you deploy your application to, let's say, your data center or to a cloud, AWS or somewhere, and it just broke, and that's the problem we would say. That's the problem we would call environmental differences. And images. So the image is kind of important concept if we are talking about container. So I would like to say images are a way that we can take a snapshot of a running piece of one container. So you can imagine you make a copy of the current running instance of your application and make it an image. And as containers are lightweight, you can share your image to the entire world. And that's exactly what Docker Hub is about. So the GitHub is used for developers to share code, and you would develop your source code, push it to GitHub, and everyone else can access to that. With Docker Hub, we don't push source code. We build our application into a container, make it an image, and then share that image to the entire world. So if I am willing to run someone else's application, I don't need his or her source code. All I need is the image. So I just run the image and the application runs perfectly. To me, these are all about business values. I mean, containerization is not a goal. It's some tools we developed to achieve our goals, to solve our problems. And for me, it's all about agility. So containerization enables us to move fast. As it's lightweight, we can make changes very fast. So we build something and we deploy it, and we find users don't like a certain part of it. We will fix it and deploy it again. That's something called continuous integration and continuous delivery, which is often talked together with containers, but that's just one part of it. The main part of containerization for me is we are able to move fast using this technology, and by doing that, we can provide more business values. And so I have been talking about container. So what is Docker? And I had that impression that Docker is usually used interchangeably with container. But to be precise, Docker is just one container standard. And I would love to use the example of shipping business. So consider Docker is a way that people use a cubic box to package things. And other technology, for example, LXD and RKT, are ways to choose, for example, a sphere, choose a triangle. It's a container, but it's not a cubic box. That's the difference between Docker and other ways. And nowadays, there are a group of people called Open Container Initiative. What they are trying to do now is they are trying to define a common way, a standardized way of defining container images. And the group was led by Docker. So hopefully, in the future, we will be able to have a situation there where we have only one way of defining containers. But I have never seen people working containers, but that's not Docker in real life. So yeah, I would say Docker is really the most popular technology if we are talking about containers. So enough about containers. Any questions to this point? Okay, then I will move on to container orchestration. What I have talked about is container, and it's how we build our application. And what I'm going to talk next is container orchestration, which means we have more than one containers at the stage, and we need to consider them. So why do we even want to do this container orchestration thing? As I was saying, container is usually lightweight. It has no operating system, and it should run only one thing inside. That makes things hard if we want to rely our application on some other parts. For example, my application relies on a database, and we are not putting database inside with our application to the same place. And we will get another container for database, maybe, or that's for outer resources. Another situation we will want to do container orchestration is if we want to do some microservices. For those of you who don't know microservices, it's a new way of organized web applications. So it's separated into different services. And Yeah, so it's different with the traditional three-tier application, and now it's getting popular, and the container and container orchestration is usually talked together with microservices. So what could be wrong if we are dealing with many containers? By many containers, I'm not saying about 5 containers, 10 containers. I'm talking about thousands of containers. So if you imagine that, a lot of things could go wrong. For example, load balancing. So I have to serve 1 million users, and all the workload runs in container. How do I do load balancing? So when the load increase, I should increase more of those. And container lifecycle. When the container goes down, what should I do? How do I get the log information out? When I want a new container, what should I provide to this container to make it running correctly? There are many problems. And solutions, there are some solutions out there. To be honest, the only thing I have used in this list is Docker Compose. For me, it's perfect for container for 5 to 10 containers. But more than that, I would say we will want something else. And Kubernetes is just another way for us to do container orchestration. So everyone sitting in this room, I bet you came here because of you have interest in Kubernetes, and the project itself was open sourced by Google in 2014, and it was built on more than 10 years of internal practice and research of a project called Borg. And the link here is actually the first commit of Kubernetes on GitHub. You can easily go to there and see what was in that commit. It was something memorable, I guess. And the word itself, Kubernetes, the word itself comes from Greek, and the meaning of that word is houseman or pilot. Sometimes you would see K8S, and it's just an abbreviation derived from replacing those 8 letters with an 8. So enough about the background. I will explain the architecture of Kubernetes from this point. So in Kubernetes, we have some concepts, new concepts here. I would draw something on this board from this point, and I will explain those one by one. So we have two concepts at the beginning is master and node. This is not the Node.js framework. It's a node, and I will start from master. Master is a virtual machine or bare metal machine, which is the manager of entire Kubernetes machine groups, and usually together we are calling them as a cluster. So we can consider master as the leader of this cluster, and these nodes are just the slaves to this master. So this node doesn't have to be a fancy machine with very CPU computing powers. Your iPhone could become one of those nodes, and Apple Watch could also become one of those. Or you can choose to buy a high-spec machine with it. It doesn't matter. As long as it has CPU and memory with it, it's fine. The master is handling all the out-facing works. So it is exposing an API, so we can talk to the entire cluster via CLI, command line interface, and GUI. There is a web UI if you chose to do that in that way. You can also talk to this API natively using REST, using HTTP request. That's something you can do as well. So what would happen is, from the user, not the user, from the application developer side, we only talk to master. We have no control of what's happening after that point. So we will give some task to this master, and master says, okay, I will do this. And it will in turn assign the task to someone here. Maybe it's I don't know. I haven't looked into the algorithm it is using to do that, but we have no control over that. So that's pretty much the cluster architecture. One other thing I want to bring up is something called image registry, aka Docker Hub. So image registry is a place, I was saying this before, but image registry, a Docker Hub is a place where people put their images. So it's public to the general application developers. And in real life, almost every company decided to build their own private image registry. So it's available internal, but it's not public, available to the public. So I guess we have enough for the architect. Is there any questions with this master and master node divide and cluster? If you have any question, go ahead.
Just one question. Are you going to touch on the master and any kind of highly available, is it a single physical data center, or if that master crashes, how can you handle failure?
That's a perfect question. So single point of failure, if we are dedicating too much responsibility to this guy. There are two ways to use Kubernetes. First, you build it by your own. So you will make those nodes, and that's the situation where you need to consider high availability of your master. A second way to use Kubernetes is use something called a fully managed service. Public cloud like AWS, Google Cloud Platform, Microsoft Azure, and Oracle, HP, Red Hat, almost every public cloud provider supports Kubernetes. So you can easily go to one of those public cloud providers and say, choose to use their Kubernetes service, and you don't have to worry about all this high availability stuff. Perfect question. Thank you for asking. Any other questions? Okay. And the first time I tried to learn Kubernetes, I was totally lost by all those concepts. Node, pod, deployment service, label, select. Many concepts if you try to look into Kubernetes. And I was really confused by the official documentation and some other resources, tutorial out there. And so it took me some time to figure things out. And from this point, we are going to change our approach. So starting from this point, I would love to ask you to do something together with me. So there are 3 ways to get started. If you want to do this together with me. So method 1 and method 2 are the same URL. If you are lazy, you don't want to type, you can, if you do a Google search, you will also have to type. But just navigate to this page. So you are on a page looks like this. I will explain what this is later, and what we are going to do as long as after everyone is on this page. Any questions? Everyone already opened the link? Okay, if you do a Google search, Kubernetes basic tutorial, and I believe basic tutorial, yeah, the second one. So, does anyone need more time on this? Okay, I will explain what we are going to do for now. So, this tutorial is something that Kubernetes provides officially on website. So it has 6 modules: create a cluster, deploy an app, explore your app, expose your app, scale your app, update your app. It has 6 modules, and for each module, it has some explanation and an interactive tutorial right in your browser. So if we go to the first interactive tutorial, it looks something like this. Interactive tutorial, creating a cluster. Everyone on this page now? Okay, so let's click Start Scenario. And I will make this full screen and change the font size. And then I will explain what we are going to do here and what is this. So this is something that we can try Kubernetes right in the browser. It is based on the technology called Minikube. So what is Minikube? Minikube is a way for you to try Kubernetes, and it pretends to be a cluster, but in fact there is just one virtual machine serving as both its master, but it's also slave. So it's kind of faking to be a fully functional cluster, but in fact it's just one virtual machine. But it has totally the same functionality with a cluster. And we are going to go over the interactive tutorial together. Meanwhile, as I am a Google Cloud Platform user, and I have already set up a cluster which has 4 nodes, exactly look like there. So I have a real cluster which have 4 nodes running. So what we will be doing here is we will going to run those commands together in the interactive tutorial. And if that makes sense, I will also run that towards my real cluster, and I will try to explain each command, what is this doing, and to try to demonstrate what's the difference between a toy setup and a real setup, if that makes sense. So yeah, let's get started. So first things first, Minikube version. You can click this and see it's running in your browser. And yeah, we are running Minikube of this version. Yeah, fine. Let's do Minikube start. So what this is doing is it spins up a virtual machine at the data center, and it is serving its shell in the browser to you. That's basically what is happening. So we have done with first step. Let's go to the second step. Second step is, this is something new, kubectl. What is kubectl is just the CLI here. kubectl. So kubectl, Kuber control, is a command line interface tool we will be using to talk to our cluster. And we can see Kuber control version, client version is this, server version is this. And if I run I can see pretty much the same thing, client version, server version. So let's move on. Now we have a cluster running, or a Minikube running in our browser. So next thing we want to do is Kuber control cluster info. yeah, after we do this, it says Kubernetes master is running at this IP address. Let's try to run this in our real cluster. It says my Kubernetes master running at this IP address, and it has some other things, DNS hipster, and a dashboard. I would say let's not worry about this. So the difference here is related to the fact that in a real cluster, we will need some extra functionality, for example, DNS and other parts. But in our browser, everything is inside one virtual machine, so we don't need to worry about that. Next thing is get nodes. We can expect that we have only one Minikube, and it's ready for us to use. So if I try to do this towards my real cluster, we can see I have 4 nodes, and each of them have a different name with each other, and all of them are ready. So that would be the first module of this, and congratulations. Any questions for this part? So in this module, what we did is we spin up a Kubernetes cluster in our browser. It's not exactly a cluster, but it's a VM pretending to be a cluster, but that's basically the idea. So if we are not having any questions to this, let's move on to the next step, which is deploy an app. Let's skip all those explanations and dive into start interactive tutorial directly. Start scenario, everyone on this page now. Oh, by the way, when you see this, command launch sh is available in here, and command not found. If you see this, do a refresh, or what you can do is you run the setup shell manually. It will start this, or you can just choose to do a refresh. I bet this is a problem on their side. So after this finishes, we can see Kuber control version, which we already seen, and get nodes. Again, just one lonely mini Kuber node hanging there. So let's continue. Okay, here is the interesting part. Get started. We are now going to deploy one application to Kubernetes. And the command we are going to use is Kubernetes run, the name of our deployment, and then which image we are going to use and what port. Let's just run this command line, and it says deployment created. And if we do get deployments, we can see we have one deployment. So I will explain what just happened after we run that command. So we use Kuber control to tell our master, now go to an image registry, grab an image, and run it. That's basically what we did. That command means. So what was happening is, in the master, it creates something called a deployment. And this deployment is responsible for managing a pod into in those slaves. So here is a pod. I will explain what those means. So this is a pod, and this is a deployment. Thank you. Okay, a pod is just a group of containers running together. So It says in this way, but in fact, we will always want to keep a pod small. That means we only run one thing inside of one pod. That's basically what we do. And after we tell our master, now grab an image and run it, it will pick one of those nodes and run the application. So, yeah, in my real cluster, I already deployed some application, and if we do get deployments, we can see, oh, by the way, Kubernetes is the name of my cluster, my deployment, my pod. If you see Kubernetes, you know that's me. Okay, so we can see now we have one deployment called Kubernetes running. And if we go back to our interactive shell, do a kubectl get pods, we are expecting to see one pod running our application. So if we do this on my real cluster, I can see it is running. So let's try something. So for those of you who don't know watch command is a command line utility that keeps running the command you give it on every 0.5 seconds. So it is running this command every 0.5 seconds. And meanwhile, what I'm going to do is I'm going to delete this pod. Any guess of what will happen after I click enter? What will happen if I try to delete one pod? Any guess?
Prompts you if you really want to delete it.
Yeah, let's see. After I delete this one, we can see the original one was terminating, and almost immediately a new one gets up and running. So that was the benefit of using deployment here. We can deploy application. We can grab an image and run a pod by ourselves. But if that's the case, when the pod goes down, we have no control over that. In order to avoid that problem, what we will be doing is we will always manage pods using deployment. So we will tell our deployment, we want that application up and running. If anything goes wrong, fix it. That's why we are using deployment. I will keep this watch pods up and running, and let's go back to our interactive shell. Let's move on, and here it says view our app. Let's just follow this. So first thing is Kubernetes control proxy. I will get this up and running and then explain what is happening. So it will try to open another terminal, and if we run Kubernetes control proxy, it says starting to serve on this. And let's go back to our original terminal. So what just happened is, remember, Kubernetes control only talk to master. What happened is we tell master, now we want to get access to your internal stuff. And now let me do that. So why do we even want to do this? Remember, we have no control beyond the point of master. So master is the manager of the entire team. We cannot ask a manager to, we cannot bypass the manager to talk to the team member. We can in real life, but yeah, you get the meaning. So after we tell our master, we want to talk to your slave, what happened is, master will open a port, in this case, 8001, right? 8001. So it will open a port, enable us to talk to whatever behind master. And we will see it in a second. So now we have the proxy up and running, and let's do curl localhost A, this port version. So basically, this is the version of API, and I will do this on my again same port, and for those of I use HTTP PI instead of curl to do some command line HTTP request because I find it easy to use and the result is usually more pretty. So if I query version of this endpoint, I can see pretty much the same similar result with this one. And this command line get the pod name from Kubernetes control get nodes and store it in an environment variable. We will just do this. And as I was doing Kubernetes control get pods, we can get the name of pods as well by just a copy and paste. That's something we can do as well. So the next thing the interactive shell is doing is trying to access the application from a curl command. And it says hello world, hello bootcamp. Now I'm running on here. So the application this interactive shell is using is some hello world application. And if we try to do something so this is my my application also runs a hello world endpoint and it returns the number of hosts it is hosting on. So what's just happened is we go into this application pod via this proxy. So there is a long line here. That's what just happened. So let's move on to summary, and we are done with the second module. Any questions? Any confusing? Anything you want to bring up? Go ahead.
Why do you want to go into the pod from a proxy? Why?
Because by default it's not open to anyone. We create a deployment, and deployment creates a pod. By default, this pod is invisible to anyone. And if we want to make it visible, we are going to introduce another concept, which I believe we will be doing for the next module or the module after that one. Any questions? Okay, let's move on to the next module. Continue to module 3 and leave, and let's skip all those descriptions. Go to start interactive tutorial. The third module is exploring your app. Start scenario, and so everyone on this page now. Okay, perfect. Again, this tutorial is get pod is doing get pods. While waiting, I will do it here. So if we do get pod, we can see we have one pod running. And if we do it here, again, one pod. Yeah, nothing surprise. And describe pods is just a way to, I don't know other use cases, but I think describe pods was usually used when debugging. So it gives a lot of information. For example, which node this guy is running on, what version it is running, and what is the image it is running. All kinds of information there. So if we try to do it, let's close someone. We can see my pod is running on this node, and it is running an image called Kubernetes of version 4.2. the status, the event it is happening. Yeah, all kinds of information is available. If you want to look at the detail of a pod, you just do kubectl control describe pods. Continue. Again, it is doing some proxy. So let's do this. Start a proxy, make it running, and then go back to our original one. So this might feel the same. Again, we are storing pod's name to. I will just do a reload. Okay. Sorry about this. I hope this time it is running good. If it is not, we will just forget this and run everything towards our real cluster. So get pods, describe pods, fine. Proxy, let's spin up a proxy and make it running. Now it is running. Oh, what happened? This is not happening to you, I hope. Yeah, let's forget about what's happening in the interactive shell and run everything towards our real cluster. So what's just happened is we run a proxy, keep it up and running, and try to store the pod name of our running pod, and then do a curl. Again, not again, but as my application doesn't have an endpoint at its root endpoint, so if I do hello, I can see now I'm receiving response from that pod. So nothing too fancy, and we can view the container logs via kubectl control logs. Let's do this. Yeah. As my application is running with a framework called Spring, we can see the log it is printing to the standard output. And these are the logs. It says it is starting on this port. And yeah, if you want to do some debugging, describe the pods and look at the logs. Continue. And another thing we can do is we can run commands in that pod. What that means is we can run Linux command on that machine. So, for example, if we want to see the environment variable, now we can do env and it will show us all the environment variables available to that point. And if we do this, we can see these are the environment variables available to our application. So when our application is running, these are the environment variables it sees. Also, we can even start a shell. And if I do this, we can see my image doesn't have a bash. That's something intentional, intentionally. And if I do shell, we can see now we are in a shell now. So I want to explain this a little bit. So in the interactive tutorial, the application developer decided to use an image which has bash available. In my application, I chose to not use an image with bash available. Why? There are pros and cons. The pros, the benefit of using more rich features is that it enables you to do debugging in a more natural way. It's just a normal Linux shell you can expect. That's one thing. But the negative part is, first, it makes your image size bigger. since you have to support bash, you have to support other things. Second is for security reasons. For example, if by any chance your application, your container is compromised, a hacker, you can imagine a hacker with the ability to access your bash with the situation that a hacker can do nothing because there's no bash available. That's just, there are pros and cons for those decisions, and choose wisely. And there are many articles and discussion on this topic, and if you are interested, you can do some search. And if I do ls, I can see, since my application is JVM application, you can see my application is packaged as a jar file. If I unzip my jar file, I can see these are the files inside of my application. So what I wanted to show here is inside this pod is just our application running there, nothing more than that. So I guess that's pretty much all of module 3. Yes. So it is go into the container. By the way, is this working on your machine? No? I guess this website went down for some reason. Yeah. Maybe too many people access at the same time. Anyway, yeah, let's forget about this, and I will try to explain this along the way. And but yeah, for now, let's forget about. So we are done with module 3. Any questions? Go ahead.
So basic question. So the example you gave was a Java JVM app.
Yes.
The actual JDK itself is inside the image.
Exactly.
Right.
Yeah.
It's packaged with it, right?
Yeah, exactly. If you are interested, I can show you the script I used to build that image. So the way I started my application is simply java-jar that jar file. So nothing fancy. JDK is already built in with that image. That's why Java works there. So next is expose your app publicly, and let's skip to interactive tutorial directly, and I hope this is back. So here it is trying to get pods and get services. Get pods, we should be familiar with this one for now. Get pods, it gives us all the information about currently available pods and services. If we let's try to do this. Yeah, now it seems to be running again. So if we do services, it is, this one is the default services running by Kubernetes. I won't explain this, but you will see how what service means soon. So let's run this. Kuber control expose deployment type node port. I will explain this, and then if we do get services, we can see now we have 2 services. So yet another new concept coming up, which is something called service. What is service? Remember, we have to use a proxy to access our application. That's what we did at the second module and the third module. But we want to serve our application to the outer world. That's where service comes in. So basically, service enables us to expose our application. That's all. And there are there are at least 3 types of services. Node port is one of those. So what node port is doing is, node port opens a port here on that node and enables outer world to access the application from this port. That's basically what node port is. And in my real application case, by the way, I already deployed my application. I am using a load balancer as a service to expose my application. By the way, SVC is a short form for services. They are pretty much the same thing. And my load balance has an external IP. If we copy this IP address and try to access it, we can see my Kubernetes application is running. So my application is just a simple counter. It gives us the information of where it is running, and we can do up and down. So yeah, it's a boring application. Yeah, so that's the application running at a public IP address. So we are now able to get access to the application thanks to service. That's basically what service is. Let's go back to our interactive tutorial. And any questions? Do interrupt if you have anything that you feel confusing. Describe services. Yeah, as I was saying, describe is a way to give us more information sometimes than we need. I wouldn't have that one, but yes, if we do don't have resource Kubernetes. Yeah. So my service is a type of load balancer, and these are the IP address. Yeah, all the useful information. So this time it is trying to access the application from node port. As you can see, it is open up a port on that node to enable us access to the application. So basically what it does is open a port here, so other people can get access to the application. But in my case, I have a load balancer. Oh, I should have drawn this. I have a load balancer out. It has an external IP serving the outer world, and this load balancer guy is doing all is passing our request to our application. That's the way that's how we expose our application. So let's continue and using labels. Labels is a concept that I will skip during this tutorial. So basically, labels is a way that we use to manage different type of resources. Let's just skip this one. So deleting a service, we are not going to delete a service. So let's skip the entire module for now. Any questions? We are done with the fourth module, and I promise you things will be becoming more interesting after this point. But before that, any questions? Okay, let's move on to the fifth module, which is scaling your app. Start scenario and present mode. Open up the font size. Yeah. So everyone on this page now? Okay, perfect. Get deployments. Yeah, let's run this. Get deployments, desired 1. Desired is how much pods do we want. Currently is how many pods do we have right now. Up to date is how many pods have changed during last time. Available is how much pods are available. So what's the difference between current and available? Current, we have 5 pods, but only 3 of them are available. What could that situation be? I would just say the answer. So usually, when we have to do load balancing, we have a mechanism called health check. So imagine we start a new pod, but it's not available yet to our customers. Maybe be it a long starting time. For example, if you are doing a JVM application, JVM startup is usually taking more than 10 seconds. So that's why we have 2 numbers here. So Kubernetes started, and the first thing it runs is scale. And let's just do this. So, but before that, I want to watch my pods before I do this. And let's say I want 5 pods. Let's see this happening. The moment I say I want 5 pods, and the Kubernetes is Kubernetes will just bring up another 4 new pods for us. And if we go back to browser and see our application, this one is coming from this guy, and let's do some refresh, and I hope they are coming from different people. Yep. And some of them are not available yet. You can see the URL are the same, but the guy serving this content is changing. Is it anyone? Okay. Okay. And as you can see, my application is not handling, so this value is stored out of my cluster, and there are some cache issue. I believe there, if you see a number that's not same, that, for example, some other pod says it is something else. That's a problem with my browser issue. That's the application issue, not Kubernetes. Okay, let's go back to interactive shell. And that's the scaling part. If we do get deployments, we can see, yeah, if we do this, we can see we have four pods running. If we describe, we have more information. So let's do this here at our, I forgot to show you of this. You can see they are running at different nodes, but these 3 people are on the same node. So remember, I said we have no control of where our application will be running inside of the cluster. That's totally up to master, and that is what just happened. We just tell master we want 5 pods, and master will grab whatever is available and run the pod for us. That's basically what just happened. And if we do we can see up to date available 5. Yeah, that's pretty much the scaling part. This is so awesome to me because you can scale your application so easily, and if you have more users than you would expect, you will just do a simple command line, and it will just scale up extra resources. But there are challenges to applications, as you were saying. In my application, I was not able to handle those the cache thing correctly. So different pods are showing different values. That is something challenging application developers. So I would say in the future, if we want to develop some application, we will want to keep this in mind. My application might be in a process of load balancing, so I don't want to store any state in my application. That's something just came to me, and yeah. Load balancing describe, as I was saying, describe give us extra information. So this guy, yeah, I think these are things we have already done. So hello Kubernetes bootcamp running on. Yeah, it is trying to show the same thing, but yeah, I think you have already seen it happens. And scale down. If we don't need those resources, we can just scale them down. And let's try to do this. And I will just scale it back to 1. And Kubernetes will just queue 4 random ones. You have no control of which one will be killed and which one will be kept. Okay, so get deployments, get pods. Yeah, I guess we are done with this part. Any questions about scale application on Kubernetes? Okay, the last module is a rolling update. Let's go to interactive tutorial directly again, as usual. Start scenario. So this module is about the problem that our application got updated. How are we going to roll out our update? That is also something I like about Kubernetes, and we will see how this works. Kuber control get deployments. I'm waiting for this guy to start him, but meanwhile we can do something like yeah, we have now only one pod running. I will just skip the describe part. Set image. If we want to change our application's image, it's just this simple. Only one single command line, we change our application. And get pods. But before that, I would love to invite you to look at my application's Docker Hub page. So on Docker Hub, my application's Docker image have 6 versions. And currently, as I was showing, this pause. Yeah, now it is running version 4.2. Let's say we want to run version 1. And remember, our application has a not fancy, but a working UI. It is built with Vue. What's going on here?
A lot of people clicking.
Yeah. It's built with Vue, and yeah, you can view. Yeah, I have a Vue front end on my version 4.2, but on my version 1, I didn't have that. So let's set the image to version 1 and see. We lost the fancy UI, but I have another way to prove that we are on the same application. So now it seems it is up and running. So in my first version of application, I didn't have a UI. What I had is just a hello world endpoint. Yeah, it says hello world serving from here. So this is so cool for me because you can update your application so easily. You develop your application, you build it into an image, you add it a new tag, you push it to your image registry, you do a set image, and it is done. And this was something very cool to me, I have to say that. So that's pretty much all of the update part. And we can see, yeah, we can see this. Describe, give us all the information. Now we get the node port. We try to curl it. It says the version is 2. Before it's version 1. And the rollout status, it will just give us the information of how the progress we have been, the progress of that rolling process. Describe false. Yeah, again, continue. I think, yeah, now it's doing another time. So I believe if we, oh, this is all of it. Yeah. Get deployments, get pods, nothing surprising, I guess. Yeah, we are done with, is there any other thing? What is happening here? Okay. Let's do something scale. First, let's scale our application to 5 and then change the image to see how things are how things are running. So we first decide to have 5 containers running, and then we decide to set our image to 4.2 back. So it will kill those containers and try to start new ones. And at the end of the day, we should have 5 containers running 4.2. And yeah, that's pretty much all of the second part. And let's go back to the slides. Any questions? If no questions, let's first do a recap fastly. So these are the concepts that I listed at the early page, and we can see. I will go over this one by one. Node is a machine is a virtual, be it a virtual machine or a physical machine. A node is somewhere with computing resources we can run our application on. Pod is a collection of containers that work together. It says that way, but for this point, just remember, one pod, one container, or one pod, one main process. If your application needs some other parts that runs together with you, and that's a design pattern called sidecar. If you are interested, just Google sidecar design pattern, and you will get more details about that. But usually, one pod, one main process. Deployment is a way that we let master to manage pod's life cycle. Remember, we kill one pod, and deployment bring up one for us automatically, so we don't have to care about those life cycles. Service is a way that we expose our application to the outer world. Without service, the only way we can access to our application is via proxy. Label and selector, we skipped this part, but because this label doesn't make sense since we have only one service. But imagine we have like 10 services, and we need to manage those services in different ways. The way Kubernetes do this is assign labels to different resources, pods, deployments, services. These are all Kubernetes objects. So if we assign labels on it, there will be a way to manage those things. For example, we want to scale service A, and then we say selectors. Yeah, selector label equals service A, and it won't affect any service B or service C. And there are other concepts, volume, config maps, secrets. I don't know enough to explain this, but I will try. Volume is, remember, the life cycle of container is really short. But what if we want to store some data? We want to keep those data persistent. That's where volume comes in. So usually, if we are doing this on cloud, in Google Cloud, Google Compute Engine has a volume system which we can show them to our application. So our application can store things we don't want to lose there. Config map and secrets are the ways that we use to expose, for example, database passwords, database URLs, or message queue URLs, endpoints URLs, that kind of thing. So when we develop on local machine, database is here, but when on Kubernetes somewhere else. So config map and secrets are used to handle those environmental differences. And beyond this, there are some resources out there. The official documentation is really could be overwhelming if you are just getting started. And there is a course on edX. I find it really good. And for people who would prefer a step-by-step fashion, that might be a good start. And Kubernetes the hard way. So what I was doing and the in-browser interactive tutorial was doing is using something already there. Kubernetes the hard way is a tutorial that leads you to set up a Kubernetes cluster by yourself. Yeah, that's why it's the hard way. And since Kubernetes is now one of the biggest open source projects out there, there are many related works starting from there. Helm chart are projects that is a package manager for Kubernetes. So if you want to package your application, for example, your application has 3 pieces, you can package them together, put them in a chart, and then people who use Helm can run your application easily. OpenShift is Red Hat's managed version of Kubernetes. So Red Hat people provide some extra functionalities to Kubernetes, but basically it's just a Kubernetes. Jenkins X gives us the ability to run Jenkins on Kubernetes. And let's revisit our objectives, and I hope all those objectives are met, hopefully. And thank you for your attention, and I really appreciate you following along, and thanks very much. Okay.
I just want to see the slide.
Okay. During the presentation, I have asked many times, but any questions?
So when you shut down an instance, how does it manage the shutdown? So let's say like you have a Jenkins cluster and you want to shut down some slaves and operate others.
Mm-hmm.
Is there some kind of proper shutdown sequence so that you don't kill the slave while it's doing work?
By shutdown, you mean kill the node, not kill the pod.
Well, is there a way to ensure that you don't kill the node until the slave has finished its work and is in a state where you can terminate it with no problems?
You mean gracefully shut down?
Yeah.
That depends on how Jenkins is handling the Linux signal, I guess. So, I mean, if I'm running my application will respond to seek term and seek queue in a graceful way. So it will finish its job after serving its last request and then shut itself down. I believe Jenkins is also capable of doing that, but I'm not sure. So, but you want to do update, right?
Well, anything that essentially means that I need to eventually get this laid down and get a new one in, whether it has some kind of security update or something.
Yeah, I'm pretty sure. I have never run Jenkins on Kubernetes, but I think if we are doing if we want to update some slave, all we need to do is update. We can talk about this later, but there are many ways to connect a Jenkins master to a Jenkins slave, SSH, JNLP, and I believe there are other ways. I don't know how that works on Kubernetes, to be honest, but I will need to look that up. But I'm pretty sure there must be a way to do things like security update without affecting the build jobs in progress. I hope so. Yeah, I'm not sure. I'm sorry about this, but yeah, that's my best guess. Yeah.
If you had any experience, I'm curious, if you were running this as a platform, is there any support for allowing logging facilities for applications across the cluster to search the logs, to archive the logs? I don't know if there's anything that's provided with Kubernetes for that.
I'm pretty sure there must be something, but I don't have one out of mind.
Okay. And then the other question is, I'm just curious, is if you wanted to do billing records, does Kubernetes have any statistics about what's being used resource-wise? If you've run across anything.
I'm not sure. I'm not sure about this, but I think so. If we go to compute engines, we can see all those four instances, and I think I can get some statistics of load here on the dashboard. I'm not sure. Seems I'm monitoring here maybe. Yeah, it gives something like this, but I'm not sure this is good enough for
building. Okay, I was just curious. Thank you.
Yeah. Maybe there is something. Yeah, it seems to be some of those. Yeah, see it by the couplet. Yeah. It seems something like this is available. I'm not sure. So,
thank you.
Thank you. Go ahead.
So Kubernetes or Docker, using Docker is lightweight solution you mentioned.
Yes.
Right. So in what way do you mean it's lightweight? I think some people says it's kind of dangerous to use containers in production environment. And,
yes.
And so it might be heavier than current environment.
I think lightweight and heavier might not they are not in the same dimension. By lightweight, I mean container is fast to start up, to start. I mean, you don't have to carry an open operating system with you. So it's usually within seconds before a container can start up. And the heavier, by heavier, do you mean that the response time is longer?
Yes, performance-wise.
Yeah, okay. I don't know, actually. So I have never run a workload on on container to support too much workload. But at my work, we did run some production workload on container, and it was supporting like 300 people, and it was totally fine. So we are serving like 10 containers almost 10 containers to these 300 people, and the performance was just okay for us. And there are many ways to avoid that. For example, you can just throw in money and make a scale up solution. That's an easy way to go. And other ways would be, for example, use Jenkins slave to offload the workload of master. Yeah. To be honest, I have never run container workload to support like millions of users. There might be performance issue, but with this scale out at hand, I don't think that will become an issue. If our application handles that well, we can in theory, we can support unlimited users.
Thank you.
Yeah.
I'm wondering if it is difficult to synchronize the data of different instances, like you showed before.
Yeah.
Well, actually, what is the typical application of Kubernetes? I mean, should it, if you run it in several instances, okay, you just put the front end on Kubernetes, and the backend on a different instance or system, or
Yeah.
and my second question is, what is the advantage to, for example, to compare to EC2 on Amazon, AWS source, or because yes, and you don't have to care about scaling up by yourself.
Yes. Actually, I heard 3 questions. The first is, how do we handle something in common with those with applications? For example, the counter example and something like in database. That's something. There are 2 ways to do this. First is you store whatever your database, your Redis instance out of this cluster. And so the endpoint is just one endpoint. And you let all your application look at that one endpoint. That's one way to do this. The second way is you put those part of your application in the cluster using volume. There is a mechanism in Kubernetes called persistent volume, which you can do such things. You can put whatever you want to share among pods there, and that's the first question I heard. The second question is front end. What to deploy on front end stuff? So for me, front end stuff could be served 2 ways. First, you serve it from a server, web server serving static files. By front end, we usually means JavaScript files, HTML, CSS. Those could be served from a web server. Another way of serving this is from some object storage. For AWS, it would be S3, and for Google Cloud, it would be cloud storage. These are just the static files, so it doesn't change too much. So I think it would be better to put those front-end stuff out of your servers. So they shouldn't go into Kubernetes. That is my idea, my opinion. This last question is, how is this different with EC2? With EC2, the way you do scaling is from the infrastructure load balancer. There are 3 types: elastic load balancer, application load balancer, and network load balancer. These 3 types do different things, but it's just hides the part for you, so you don't have to deal with that. But behind the scene, it is still happening. I believe there is a way to hook up the monitoring of resource usage to auto-scaling in Kubernetes as well. So if we can achieve that, basically we are doing the same thing. We are responding to a user load increase and decrease and we chose to increase more or decrease, making more pods or kill some of those pods. And you can also run Kubernetes on EC2 as well if you want. Go ahead.
You mentioned the sidecar pattern
Yes.
in the presentation. Does that mean, for example, that within your pod,
Yes.
so you have your application logic, which is code, which is what you compile code which is running,
Yes.
and you would have like a database as well, or
No, I would never say putting a database inside of pod is a good idea. Maybe some caching, for example, I think it would be okay if you put a Redis inside a pod, but definitely not a database. For sidecar, I'm not sure whether you heard about the istio, ISTIO. That's something which used to serve as a proxy for your application in microservices setting. So if that's the thing you are talking about, we will need some proxy beside our application. So these two things always move together. If that's the case, we put those two things together in one pod. But main process is one. The application should be the main process. Sidecar is just there for help. Hope that answered your question. Any other questions?
Sorry.
Go ahead.
So in this example, Kubernetes is running on GCP,
Yes.
Google Cloud
Yes.
Platform.
Yes.
So can we change the instance type, like in Amazon AWS, we can choose instance type, right?
We can. We can change it. Here is a place where we can change the machine type. It's fixed. N1 standard one CPU. So yeah, it seems no. But we can change the number of instances here. Yeah, I have never.
Maybe we can change. In this page, it doesn't look like. But
Yeah, in compute, let's see whether we can change items. I don't know. Yeah, maybe not.
So
Yeah.
you can easily spin up another instance with better
Yeah.
classic and then just port the image to that.
Yeah, it seems that machine type cannot be changed.
Oh, thank you very much.
It's okay. If there are no further questions, I would say thanks very much for coming, and I really appreciate your questions and attention. Thank you. The meetup ends here, right?
Yay, thank you, Jia.
Yeah, and if you want to chat around, feel free.